Hello, everyone. My name is Franklin Lewis. This is my final project for the course SU22 Data Visualization 8101. My project is about Kobe Bryant career analysis. And this is an individual project. Introduction about Kobe Bryant. Kobe Bryant was an American professional basketball player. He spent 20 years with the Los Angeles Lakers in the NBA. He is widely regarded as one of the greatest basketball player of all time. Bryant has won 5 NBA championships, was an 18-time All-Star, a 15-time member of All NBA team, a 12-time member of All Defense team. In 2008, he has been awarded as the most valuable player, and 2 times he is the finals MVP for NBA. A brief introduction about the project. The sports performance analysis has been recently adopted by many sports and the teams, not just the basketball, so be it Formula One, NFL, tennis, cricket, and all the sporting, they are adapting to the sports performance analysis. The analysis enables us to optimize the player performance, which gives the team the edge. With the analysis, the science of creating the data about the players. This can be done by observing the players during the matches or the training sessions. This can be put together with the latest technology to analyze the advantages, disadvantages, and area of improvement for the teams and the player, and also to analyze the opponents. The technologies I used is Python 3.9, Pandas, NumPy, Seaborn, Matplotlib, and Jupyter Notebook. The motivation, what motivates me to take up this project is basketball is one of the favorite sports across the globe, and probably the second or third most favored game in the USA. So US have won medals in the Olympics. NBA has been very famous and has like 30 teams, and it's one of the major professional sports league in the US and Canada. Though there were a lot of advanced analytic tools and analysis tool that's currently available in this project, I'd like to sharpen my skills by using the data and understanding some of the areas of the all-time great Kobe Bryant. This project will be helpful for the below items, like the player performance analysis, identifying player strengths and weaknesses of the players or the team or the opponent, the game strategies based on the analysis, and also can be used for the NBA draft. The existing work, there are a few products that's currently available in the market. One is the Sabermetrics. And recently, Nova Basketball has been very famous. Nova Basketball is an affordable product that records a player's shot through a camera. Then the Nova track the shots, arc, left, right movements, and percentage, and ultimately a player consistency. Nova has currently been used at every level of basketball, has a track over 260 million shots. This is a screenshot I took from the from site. This is their Nova takes is a data service that tracks a player shot anywhere in the basketball court, providing the instant feedback on how the player should adjust their shot. The system uses the latest computation technologies, algorithms to track the important data points, such as where the shot originated from, where the shot scored, the angle, the shot depth, ball velocity, the left-right position of the ball, with the sensors mounted like 13 foot above the rim. So Novaltics captures the position of ball 30 times per second, analyze the trajectory and the ball position within the rim, allowing the players to pinpoint how increase their shot shooting percentage. My contribution, because the statistics can be used across all, especially with the sporting domain now. I thought maybe basketball is an area where I thought I can explore, because with the data available for the team or the individual players. So I picked basketball and Kobe Bryant. My contribution is by generating visualization of Kobe Bryant's performance. Some of the things I covered is analyzing Kobe Bryant's strength and weakness area in the basketball court, opponent-wise performance by Kobe, um, shots played by the Kobe, and shots played by in zones. So the data I've downloaded from the kaggle.com. This is a screenshot of the CSV file. Some of the key components that I used is the action type, then the season, seconds remaining, shot distance, shot made flags, the shot zone area, and the opponent and the year. This is the first visualization. This is a shot attempted by Kobe. The about chart, that chart shows the number of shots attempted by Kobe every 24 seconds from the start of the game for the entire career. The silver bar is a separator that says which ends each quarter of the game. Some of the key attributes that I used are elapsed game start and the period. From this graph, we can see Kobe's shot attempt during the initial period of the second and fourth quarter is less compared to the first and third. Also, we can see there's an increase in the shot attempted by end of every quarter. I used histogram because I wanted to find the frequency with the 24 seconds, since the histogram can bin and the data returns the count. This is the Jupyter notebook I used. Data load, all those included, and then I built that. I use the bin and histogram and the figure size, and then binding the data in it. The next graph is short distance against all opponents. The graph shows an average distance from Kobe Bryant shoot against all the opponents. We could see the longest shoot is with New Orleans, and his shortest distance with the Vancouver. I used a scatter plot because it gives a clear visualization. And this is the Jupyter notebook code. I used the opponents, the distance, and the scatter plot. The next is the shots hit and the miss against the opponent. The chart shows Kobe shot hit and versus a miss. The year 1996 against the opponent, we can see Kobe has the highest hit with Portland Trail. The key component attributes I use is year, opponent, shot made, hit, and then whatever the shot made flag that is missed. Shots played throughout the career. So the chart shows whatever is marked in the blue with the O, that those are the shot has been shoot that has been hit, and whatever is the X in the green or the shot that was missed. I use the location Y and location X, which shows which position Kobe was in that court, and then with the count of shots, shot made, I can build a plot with looks like what the areas where he has played well. So this is the Jupyter notebook code where I use the blue and green, and based on the time building the plot. This gives an idea what are the places he has been confident. I mean, his strength in areas where he can play the shots, and these are the outside code. And this is the chart that I built to show the zones where he played the shot. So there are 6 zones in the basketball code. That is the right side, left side, left, right side, center, right side, center, center, and the back code. These are the called as a back code. This graph has segmented the shots into the shot zone area. This shows that Kobe is very efficient in the left side and the right side, and also his strongest areas between the center. Some of the key attributes I used is shot zone, the area, the shot made, whether a hit or a miss. This is a hit, sorry, and the X, the position that he played the shot. The conclusion is from the analysis, I can say by using the available data, and with the latest technologies, we can create visualization which can help the sport improvement. The stats can be used to identify the strength and weaknesses of the player or the team. This can also improve the player performance, so that key areas to improve, and the strategies we can build based on the player's key strength and the weakness. By applying the latest technologies like machine learning, deep learning algorithms, we can build a predictive analysis that can build models, and we can present it and take that visualization and the analysis to the next level. And these are the references that I used for this project. And once again, thanks for spending the time, and it's been an amazing journey in this course. And thanks for giving me opportunity to present my findings. Thank you.